When dealing with multiple service disconnects in a common grounding electrode, it's crucial to size the grounding electrode conductor correctly. The National Electrical Code, or NEC, provides specific guidelines for this. In the scenario described, there are 3 separate 200 amp service disconnect switches, each fed by 4/0 copper service entrance conductors. These 4/0 conductors are tapped from a set of 500 cm copper conductors located in a trough ahead of the disconnect switches. The building's sole grounding electrode is a concrete encased electrode. The question revolves around determining the appropriate size for the common grounding electrode conductor that connects the grounding busbar to this concrete encased electrode, utilizing the method permitted by NEC section 250.64. D1.3. This section addresses the situation where multiple service disconnects are supplied by a common service. The key is to understand how the code addresses the sizing of the grounding electrode conductor in such a configuration. NEC section 250.64. D1.3 allows for the connection of grounding electrode conductors from multiple service disconnecting means to a common grounding electrode conductor or grounding electrode. This is where the taps to the grounding busbar come into play. The taps are sized based on the size of the ungrounded service conductors feeding each individual service disconnect. In this case, the 4/0 copper conductors feeding each 200 amp switch are the determining factor for the tap size. According to NEC table 250.66, which is used to determine the size of grounding electrode conductors for alternating current systems, a 4/0 copper service entrance conductor requires a number 4 copper grounding electrode conductor. The table correlates the size of the service entrance conductor to the required size of the grounding electrode conductor. Note that table 250.66 provides the minimum size requirements. In this scenario, the taps from each service disconnect to the grounding busbar are number 4 copper, based on the 4/0 copper service conductors. Once these taps are connected to the grounding busbar, the question becomes what size conductor is needed to run from the grounding busbar to the concrete encased electrode. This is where the main grounding electrode conductor comes into play. To determine the size of this common grounding electrode conductor, we need to consider the total size of the service entrance conductors. While each individual disconnect is fed by 4/0 copper, the main service conductors in the trough are 500 cm copper. Therefore, the common grounding electrode conductor must be sized based on these 500 cm conductors, not just the individual 4/0 taps. Looking at table 250.66, for a 500 cm copper service entrance conductor, a number 1/0 copper grounding electrode conductor is required. This is because the table links the size of the service entrance conductor to the minimum acceptable size of the grounding electrode conductor. Therefore, even though the taps to the grounding busbar are number 4 copper, the conductor running from the grounding busbar to the concrete encased electrode must be a number 1/0 copper conductor to meet the NEC requirements for the overall service size. It's important to remember that the grounding electrode conductor ensures a low impedance path to ground, facilitating the clearing of faults and protecting equipment and personnel. Undersized grounding conductors can impede this process and create unsafe conditions. When installing or upgrading electrical services, always consult the latest edition of the NEC and local codes to ensure compliance and safety. In summary, while the taps from the individual service disconnects to the grounding busbar can be number 4 copper based on the 4/0 conductors, the common grounding electrode conductor connecting the grounding busbar to the concrete encased electrode must be a number 1/0 copper conductor as dictated by table 250.66 for a 500 cm service entrance conductor. Always prioritize safety and adhere to the NEC guidelines when working with electrical systems.